Hello, dear students. Welcome to Hybrid Learning. So, today's topic is heating effect of electric current. This is the continuation of the last video of electric power. This is particularly for CBSE grade 10. So, let's get started. So, now heating effect of electric current. So, we know what is an electric current. We have seen the potential difference. We have seen electric power. We have seen the different circuits. Now understand, in a particular circuit, right, you connect a battery, okay? So what is this battery or a cell? It's the source, right? It is the source of creating that current, right? So now once you connect the source to it, okay, what does it create? It creates a potential difference between the terminals of the circuit, as a result of which the charges will flow across the section, and when the charges flow, it produces a current. So this is what we understand. Now understand that if you have to maintain a constant current throughout the circuit for doing a certain amount of work, so what you will do? You have to keep the potential difference like that. Then only the current will flow basically. As a result of which you have to use certain amount of energy, right? So you have to expend that energy so that the continuation of the current takes place. Now, understand, where does this energy go, right? So there are two parts of this energy. A part of this energy will be used in maintaining the potential difference, maintaining the current, as a result of which we'll get some useful work. And another part of the current will be used to expend in heat, which raises the temperature of the particular circuit or the particular gadget. So you might be thinking that, okay, one part is useful, but the another part is not useful, right? Yes, that's it. Because the part that is basically which we are using for useful work, that is a section which is advantageous. But the other half is not advantageous because if it raises the temperature of the gadget, in some cases it can get destroyed. Like understand, if you have an electric fan, right? The fan is rotating. So when the fan is rotating, it is creating a useful work. But if you turned on the fan for a long interval of time, there is a possibility, there is a chance that it will get warmed up. And the coil inside might not work after some time. There is a possibility that will happen. The same thing happens when you keep on a lamp turned on for a long time. You will see that the bulb heats up. So as a result of which, if you keep it for a longer time, the gadget won't work. So this rest of the energy that is being expended as heat is not good. And this is what is the main topic today. That is the heating effect of electric current. But understand the fact that not every time it is disadvantageous. Because if you see some daily appliances like electric steam, electric toaster, many other examples are there. So in those cases, what happens? So if you have a purely resistive circuit, so if you send current through it, there will be generation of heat. But the heat in these cases are being used for useful work. We are using electric steam, we are using the iron, we are using our toaster, right? So the heat is being utilized. So that is the major understanding of this topic. Now today, the main part that we are going to cover here is how do we get it, or can we mathematically calculate the heat generated? Yes, we can do that. So for that case, what do? We take a circuit. In the circuit, as you can see in the figure, there is a resistance R, there is a voltmeter connected, there is a key connected, battery is there, and ammeter is there. Current is flowing through the circuit, right? So now what will happen? So the current is flowing, that means charge is flowing. So from one end to another end, if the charge flows, that means you need to do a certain work on that charge. So now doing a certain work done on a charge is nothing but the potential difference. So how do we calculate the work done? We know that calculating the work done is nothing but potential difference into the charge. Very well enough. So from after knowing the work done, we can calculate the input power. What is the input power? Power is equal to potential difference into Q by T, which can be written as V into I. Now we have done a detailed understanding and derivation of this formula in the last video. I'll add the link in the description box. If you have any doubt, please go check it out. So we got our power, right? So now after getting the power, the same thing. So now we have to find the energy from the same formula. So what is the energy now? So as you can see here, the energy will be nothing but power into time. So my power is VI. So if I multiply it with time, that is VIT, that is my energy, right? So what happens to this energy? This energy basically gets dissipated in the resistor as heat. So that means I can write the heat produced in this kind of circuit is nothing but VIT. So it's the product of potential difference V, current I, T is the time through which the current flowed in the circuit. This is my heat generation. Now we can do a little bit more modification. We can apply Ohm's law here. So if I write V is equal to IR, then I will get H is equal to I square RT, which is a very famous formula which is known as Joule's law of heating. Now what does it states? As you can see in the formula, it's very easy to remember. If you remember this formula, you can always remember Joule's law of heating. So there are three parameters: current, resistor, and time. So that means the heat produced in a circuit is directly proportional to the square of the current. It is directly proportional to the resistance in the circuit. It is directly proportional to the time taken. These are the three parameters. Now, obviously, you can understand current, if the current is more, so heat generation will be more because it is dependent on the square of the current, which is very important. Again, resistance is another factor. So the more the resistance, the more the heat will be generated. And obviously the time factor, because if you keep the circuit on for a much longer time, then again the heat generation will be more. So please remember this formula very carefully, okay? Because this is the famous Joule's law of heating. This is very important for your exam point of view as well, okay? So I hope you understand everything, okay? So if you have any doubt or anything, please let us know in the comment box, okay? Please check it out the previous video and like our channel and subscribe. Thank you. See you on the next video.